Lesson 5, 1.5 in Module 1 here is on proportional relationships. You can see I'm in my classroom right now, so no cameos by Jack today. But this is going to kind of wrap up what we've been talking about with proportional relationships and the different ways we can represent them. So let's get right into it. Proportional relationships. They represent a constant rate of change. Remember, when we were finding that constant, we were finding that, no matter what we divided, we always got the same thing we're going to multiply by. So it's constant, it's not changing. Two things are going to be true about a graph. The graph will be a straight line. And it's going to pass through the, hopefully you're all saying origin to yourself, or 0, 0. And what we first started doing is if we wanted to check for equivalent ratios, y divided by x, it will always be constant. And that's what we are looking for in tables. Okay, so these things describe what it means to be a proportional relationship. Again, you're going to find some things that maybe aren't straight line or they're not a constant. There's nothing wrong with them. They're just not proportional. So let's check out the different ways we can represent all these things. Okay, so we're going to apply what we just talked about as a graph, as a table, as a verbal description. We're going to talk about it being proportional and as an equation. We've done all of this stuff. Now we just want to see how it lines up when we put it all together. The number of miles a white-tailed deer travels is shown in the table below. We got to complete the missing information. Well, I know when I first looked at this, I thought there was a whole bunch of missing information. But let's focus right here. We have a little bit of information right here and right here. Oh, and that did not copy real well. I will tell you, oops, I guess light blue. That's supposed to be 196. Sorry about that. Anyway, so this is representing the number of miles, 84 miles, a white-tailed deer can travel in an hour. Notice put my X and Y up there. So if we want to figure out their constant, we're going to divide. So I'm going to go 84, that's a 4, not a 9, divided by 3. Get 28. We can do the same thing here, make sure. 196, y divided by x, divided by 7. 28. Okay, oops. So that means our k, oh, that's a y. Don't know why I wrote that. Our k is 28. Now, I might jump around here a little bit, but you don't have to feel like you have to go in the same order I do. You might jump to write an equation right away. You might be able to write a verbal description either way, right away. Doesn't matter. Okay, we're going to do all of them. So I am going to jump to an equation real quick because remember our equation is whatever k is times our x. Remember our k is what we're multiplying by. So I am looking for what we're multiplying by. So we're just going to go y equals 28 times x. But somewhere along the way, we learned that it's not necessarily the best thing to use x and y. It is to graph it. But notice our x's are hours and our y's are miles. So instead of y, I could say the number of miles, m, equals 28 times the number of hours. And put an h there. Might make it a little bit easier because then what we can do right here is we know we're just multiplying 28 times the number of hours. So I can go 1 times 28 and get 28. I can go 2 times 28 and I get 56. 3's done. 4 times 28. And just looking at my notes here, you type this absolutely into a calculator. 140, if you wanted to see that. So I'm just going to multiply all my number of hours here by 28. Again, our constant is what we're multiplying by. And that goes 168, 224, and 252. Okay, so now we got a table filled out. So let's say I wanted to go to my graph now. Okay, so there's going to be approximation here because I only have so much room. But notice I'm going 1 through 9 here, and this is going to be my x-axis. This is going to be my number of hours. And so I'm just going to go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here I'm going 28 down to 252. I kind of figured this out earlier, as this represents miles as I tried to write sideways. I think I'm going to go by 25s. So 25, 50, 75, 100, 125, 150, 175, 200, 225, 250. It'll be close. Now notice I didn't write in all the scale, but it's equal. Even though I didn't write 75 here, we can see 50, 75, 100. Okay, and then I'll change colors here. I'm just going to plot these points, because remember, we can think of this as 1 and 28 and 2 and 56, because we have our x and our y coordinate. So 1 at 28, there's not exactly 28 here, so you just kind of got to approximate it. 256, 384, so that's 75. 84 would be somewhere in there. 4, 112, 5, 140. Now, what should we be anticipating this line is going to look like? Hopefully, we see that it's straight. Okay. Now, it's not going to be perfect because there's some human error in here. 6, 168. But it should be pretty darn close. Oh, 7, 196. It's almost to 200. 8, 224. Just about. 225, and 9, 252, I'm just going to go off just a tiny bit, okay? And we can see that this line is straight, and it would also go through this origin. Makes sense. If we're talking about white-tailed deer traveling 28 miles per hour, if they travel 0 hours, they're going to go 0 miles. So let's put that into our verbal description down here. Again, if I'm going too fast, feel free to pause and catch up. So verbal, just words. And so we're going to say a white-tailed deer, because that's what we're talking about. Travels at a rate of what? Well, what is we multiply by each time? 48 or 28 miles per 1 hour. Now, these all are saying the same thing. This table, this is representing going 28 miles per hour. This graph, notice every hour we're increasing 28. That represents 28 miles per hour. The equation, 28 miles per hour. The description, 28 miles per hour. So let's talk about proportionality. What does it mean to be proportional? Well, right up here, there's a constant rate of change. It's a straight line, goes to the origin, okay? It has a constant. So we can say constant rate of 28 miles, I'll just go off the box here, per hour. Now remember, that's our K. That's our constant. We found that, we can see that here in our equation. We can see it here as our rate of change. We can see it here finding our K. Then notice when we talk about a graph, the graph looks like a straight line. And the other thing for a graph appears to go through the origin. Sorry, I'm getting sloppy again. So in today's lesson, not necessarily new stuff, but we're kind of putting everything together. We're showing how all the work we do with tables and graphs, they're all showing proportionality. They're all representing the same thing, our proportional relationship.